today I'll talk a little about Deno, and especially why you think you should care. So I'll present some evidence, and hopefully by the end of this talk you'll have uh, a few reasons of why you should keep an eye on Deno. So to present myself first, so am I? My name is Alexandre Santos. I'm a Portuguese guy, 27 years old, from Ericeira. I was always involved in the JS community, so a big fanboy of JS. I'm an occasional blogger and writer, and I was always passionate about products and startups. So this is what led me to the KI group, and especially to KI challengers. We call ourselves like venture builders, as Rita presented very well, and we really like to work alongside very creative people and companies who want to bring their ideas to reality, to solve their customers' problems, and we believe we have the right know-how on helping them on doing that, from product discovery to product development to growing a team, to making sure there's a team in place, there's a company in place that works and has all the conditions it needs to build a product and to build a successful product. Yeah, so on the last 2 years, so I was been involved with Deno, so I was very interested from it from the moment it was first presented, like version 0.1 or 2, when Ryan presented it at JSConf, and lately, like in the last year after version 1, I started to went a little deeper on it, to explore it in more real use cases, and to have a very formed opinion about it. And hopefully what I learned throughout these 2 years will be helpful for you, and will be a nice sum up if you want to know more about Deno. So I'll not do more time, so just what I'll talk about. So I'll talk a little about Node, and please bear with me. I know like we're all familiar with Node, we know what it is, we know that's great, but I'll pick up some parts of Node and explain from there why Deno derived, and with that I'll explain the whys behind the Deno's creation. Then I'll go a little bit on the Deno's architecture and internals for those of you that like to have a look under the hood. Then I will explain what it brings to the table together with a demo, which I think is the most interesting part, where we will live code a bit using Deno to see to see its capabilities. And then I'll have a what's next section, in which we'll quickly explore what's been happening around Deno, what are the plans for the future, and then we'll have a small giveaway at the end, and a Q&A session as normal. So yeah, with no further ado, Node.js. So yeah, once again, I will not bother you too much with this. So we all know, like Node was created back in 2009, and it questioned questioned the way many runtimes languages were dealing with I/O. So if I/O is something that takes a lot of time, why look at it in a synchronous way? So there's two options with that. You either stop the world and your code stays there, not executing anything until I/O finishes, until you read the file, until network call is finished, or you have to deal with complex threaded environments, and both of them have downsides. At the time, Ryan thought, why not use those resources? Instead of stopping the world, we can delegate the I/O to the underlying operative system and go fulfill other requests, other tasks. And yeah, this led him to choose JavaScript and to bring it to the server, as JavaScript is an asynchronous by default language. So it was created to add this interactivity to web pages, and we were very used to event listeners, to callbacks, and so on. So all of that made JavaScript the perfect candidate. And of course, so it enabled many different use cases, pushed the language forward a lot, and established itself as a success and as a low-level, purely event and non-blocking infrastructure, which we all love and use every day. But I would like to have a perspective, and before we look into Deno, I would like to look at JavaScript like 12 years later, its creation. So it's no doubt that Node pushed the language forward. So it was one of the big responsibles for its huge adoption. But at the same time, to do that, Node had to invent features that weren't part of the main language. I'm talking of things like the common JS modules. So there was no way in JavaScript to import modules that wouldn't be with a script tag, and that led Node to invent common JS modules. JavaScript also didn't have a way to deal with binary data. There weren't typed arrays and all of those things. And in order for developers to be able to do something meaningful with JavaScript on the server, Node had to invent those features out of necessity. It also created, of course, a standard library for its needs, so to access the file system, the path, crypto APIs, and so on. So all of that was created together with Node at a time where JavaScript didn't have many of the features it has today. This, and with JavaScript, with JavaScript in Node providing a very low-level API, also encourage people to create loads of modules. We all know of LeftPad and those one-liner NPM modules that people create and use, and that can be both a good and a bad thing. And of course, so Node essentially enabled accessing system resources from JS. So you can now use JavaScript to access file system, networking, and etc. But this came out with a few identified problems, and especially when you look at it 5 years later. I mean, in no way bashing in Node. I love it. I will continue to use it, but I think there's space to look at it with a critical point of view and identifying some of its pains. And so one of them is the evolution of JavaScript. So JavaScript evolved a lot. Organizations like the ECMA International were created. They were thinking of the language. They were designing it carefully so that it grows sustainably. And some of these features that were before invented by Node, like modules, were added to the main language, the official language, in a different way. So common JS modules, even if we look, for instance, at the name of this meetup, so require LX, this is not even a valid syntax of the ECMAScript language. So if you run that in the browser console that doesn't exist, because require these common JS modules was something that was invented by Node. And it was great at the time, but now it kind of conflicts with the ES6 imports and so on. The same is true for buffers and for many other features that Node had to invent at the time, but that are now added to the language. This generated kind of a mess and made it very different to develop for Node or develop JavaScript on the server side on Node and JavaScript on the client side. It's the same language, but has lots of details that kind of shift the mindset. And of course, as these problems started to appear, third-party solutions were created to match some other language. I'm saying things like Babel, where you had these features working on browsers, but then you want to have ES6 imports working on Node, you have to use tools like Babel and bundlers and so on. And this, even though it solves the problem, it has lots of complexity. Then it was due to its huge adoption and the way it grew, it was really hard for Node to keep up. So even today, when a new feature is released on the ECMAScript and on browsers, Node has a hard time updating itself so that those features are also available on Node. So there's lots of legacy, and Node is kind of slow to move nowadays. And yeah, the fact that its core is written in C++, which is not the more trendy language nowadays, doesn't help. So all of this kind of made Node a little slow, a little harder to iterate, while we see browsers adding features on a daily basis to JavaScript. Then this dependency hell, and this is of course arguable, but the fact that Node provided very little functionality, so the Node standard library provided very little functionality, led the community to create very small modules of features or functionality that was pretty much critical, and it led to this dependency hell, where we have projects that import libraries, and it's this huge dependency graph. The fact that Node standard library, the FS, the file system module, the path module, and all those modules are versioned together with Node also doesn't help iterating it. So whenever there's an API change that needs to be done in one of these modules, a new version of Node has to be launched, and this kind of made it even harder to iterate. Then yeah, the lack of standards. And of course, so this is also arguable, but back in 2009, we didn't have many of the needs, or the needs that we have today weren't de facto standards. And the fact that Node did not provide any of those things, like tools for testing, linting, dependency management, made it hard for new developers and even for us to jump across project, because you get into a project and you have one testing framework and the other you have another testing framework. The same is true for dependency management, linters, bundlers, and so on. And it started simple. So Node started very simple. You would just runtime, you would execute it against a file. But nowadays, to get a project to work, you have to install a huge load of tools to do what we nowadays consider basic, which is formatting code, testing, running code, bundling code, and so on. And then, yeah, security, or some parts of the security, weren't a concern at the time Node was created. So Node used V8, a secure sandbox, to run JavaScript code, but the way it found to have access to the underlying operative system and to the machine below was by poking holes on this sandbox. So V8 is a secure sandbox, it's the same used by browsers, but the way Node created to access the underlying resources was by poking holes, by the so famous node bindings, which are basically allow us to, from JavaScript, call C++ modules that have direct access to network, to hardware, to file system, and so on. And this kind of breaks the purpose of the sandbox, and there's no way nowadays of limiting what a node script has access to. So if you run a node script, it will have the exact same privileges that you have on your operative system user. So, and if we take a step back and remember how many npm installs we do daily, and how many of those have pre-install and post-install scripts, so we run thousands of node scripts every day, and you have no way of controlling what they're doing. We have to trust, and it's been working fine, but yeah, so those things about analytics and about making network calls and so on. So that's something when we run a Node.js script, we don't have any control. So by looking at these 5 challenges, my question is if there's space for innovation. And I think the space for innovation is not on the language itself, because I think the productivity we have on JavaScript is unquestionable. So we can very easily wire up something in JavaScript, prototype, test to see if it works. And if we validate the idea, we can very quickly start to add layers of reliability. It can be via TypeScript, it can be via adding more strict coding standards. And JavaScript gives us this capability. So I think JavaScript is nothing to be ashamed of. But nowadays, we know very well what we need on the code base. And once again, bundler, linter, tester, formatter, all of those are needs that we have nowadays, and that are very concrete. And as I said, we also want to use the same browser JavaScript. We want as little context shift as possible. We want to use the same language, the same features we were used on the client. We want those to be present on the server. So if we want to import a module and we're using JavaScript, we don't want to think, where am I? Am I on Node and I will use CommonJS modules? Am I on client and I'll use import ES6 imports? So, and of course, we want the language to evolve fast. So we want to establish practices that make it possible for the language to iterate fast while delivering features to our users and not breaking stuff. And this was what made the creators of Deno question it. And Deno is actually a still play with the words of Node, if you haven't heard of it. So Deno is a simple, modern, and secure runtime for JavaScript and TypeScript. It uses V8 and it is built in Rust. So this is from Deno's documentation, and Deno has like this 5 selling points. So it's secure by default. So everything it runs is sandbox, and we'll explore that in a minute. It has first class TypeScript support, which means that you can write TypeScript and Deno will take care of transpiling it and running it on JS. It provides, similar to Go, the complete toolchain in a single executable file. So you have linter, formatter, tester, bundler, all in the single 15 meg file. So all you need is to run a project stably is there. It has a more complete and full-featured standard library, which is not included in the runtime. So it's just a set of files and functions which are audited by the official team, but that provide the features that we normally need, from formatting to logging to HTTP to network communication. So all of that is included on the standard library, and you can just import what you need. And one of the big selling points is that it's fully ECMAScript compatible. It means that code that runs on the browser will run directly, the same code will run directly on Deno. So Deno does a huge effort to make this a reality and mimics the browser's APIs in 100%. They're currently even running the web platform tests, which are the ones that Chrome, Opera, and so on run to guarantee that browsers are working as they should in terms of JavaScript. They're running that against Deno with great results. Yeah, so before we go into the demo, I'll just explain you what happens on the Deno's architecture. So here on Orange we have V8, so it's the same thing as Node. So we have V8 where the JavaScript code runs, where Deno code runs. But the difference here is that on Node, when you do a call, it calls a direct binding on Node core. And what Deno did was to create is to make this communication via message passing. So here where this Deno buff, and what it does, it sends messages back and forth to the Rust core, and that Rust core then evaluates. So is this operation trying to access the file system? Yes or no? Does this program has permissions to access the file system? Yes or no? And based on that, and this happens to the file system as it happens to the network and so on, and we'll see that in a minute on the demo. Then he uses Tokyo, which is a thread pool in Rust, to do the same exact job as the event loop. And yeah, and of course, these threads on the thread pool are the ones, the same thing as the event loop, which connect to stdio, TCP sockets, to processes, and so on. So the biggest difference here is this message passing channel, which is the only connection from V8 to the exterior, and it just sends buffers back and forward. But yeah, so no more words. Let's go to the demo. So what we'll do here, I'll try to have a very simple example so that we can explore Node. So what we'll do is, let me know, are you seeing it properly? Are you able to see it? Is it big enough? I'll assume so. Okay, so imagine that you have a list like this, which is a txt file with names of people, and you wanted to transform this into a JSON that basically says names, and it's an array of those. That's the very small first program we'll build in Deno. So I currently have Deno installed, so the installation is quite simple. So it's just a curl or a download of, you can even install it with brew, of a shell script which installs the binary. And I also have VS Code with the official extension that gives me the autocompletes and so on. So what I'll do here is I'll create a small program which I'll call lines to JSON, which should parse this file and return the JSON output. So I'll use lines to JSON, and I'll write it in TypeScript because, as I said, Deno as a first-class TypeScript supports. So imagine that, yeah, we have this function, which is, I'll call it lines to JSON, and this function will receive a text, which is the text with the new line characters, and we'll have to return this as a JSON. So what I'll do is I'll have the result here, which is text split by the new line characters, and then I'll return a JSON. And I'll have another parameter here, which will be the key of this JSON, which it will be lines for now, but it's customizable, of course. So, and with this, we have a function that will parse, when called, parse this file and return every line as a JSON item. But yeah, we could, of course, write the rest of our Deno script here, but I'll create a new file called CLI where we'll do that. So it will be TypeScript 2, and we'll import the function that we just created. So note how these imports are absolute imports, and when I say absolute, like they're relative, but they have the file extension. So these imports, as I said, code that runs in Deno runs directly on browsers too. So when on browser, when inside a script type module, that's how you import files. We import with the full path. So Deno does the exact same thing, so that there's no module resolution magic, no go to this folder, fetch the index, but if it's on node modules, you go to node modules and fetch the main file. So all of that happens in Node doesn't happen here. So when here, what we'll do is, so as this is a script, we'll go grab the file path of the file that we want to read from the arguments of this script, and then we can even check if it's not here, but that's very important. And what we'll do is then we will use Deno's APIs to read this file. So it'll be something like CLI, and then I say team members' names, txt, and it should read this file and print JSON to the console. So what I'll do, I'll use some of Deno's APIs, and bear with me, we'll go to the documentation soon. I'll use these APIs to read this file. So read text file. You notice I have autocompletes because all of these, all of Deno's have APIs have promises and have top level await, of course. And they all have very precise TypeScript types, so this helps a lot. Even if you're not using TypeScript, you have these beautiful autocompletes. And yeah, so it should read the file, and it should log it to the console. And I'll do it this way. So it should log it to the console as JSON. So I have my file contents. I'll print it this way. So now it's where we execute our program. So our program is just this. It doesn't do anything special. It gets an arg, it reads the text file and prints it to the console. And yeah, so we'll use this Deno binary. So the Deno binary has many commands. We'll use some of them throughout this demo, but it has a REPL, same thing as Node. So we can just use the REPL. But yeah, that's not what we'll use. So we'll use the command Deno run. That is the command we use to run scripts, and we'll point to our script. Let me see if I'm in the correct folder. All right, so then I want to run my CLI. So I'll say that Deno run my CLI. And yeah, okay, file path not present, so my file is living on the same directory now. Okay, so Deno CLI, I have the file here, it's team members' names, it's this file containing the members' names. I'll run it, and it says, okay, so your program is trying to access this team members' names file. You need to give it reading permissions. And for this, we can say, okay, I want to run, but I want to give reading permissions, allow read to the local, to the same folder I'm at, then it will work. Yeah, and you see, so great success. We have our program fetching the file, splitting it by lines, and printing it as JSON. But what if our script tries to access, for instance, the environment? So if our script tries to get, for instance, the path variable from my environment. If I try to run it, part of it will work, but then we'll have this uncaught permission denied, that the script is trying to access something that doesn't have the permission to. And of course, this can get very boring, especially when you're scripting. If you're building a complete program that you know what permissions it needs, it's very cool because it's strict. But for these scripts, Deno has something like these prompts, where very similar to what applications do nowadays. They ask you, so this script you're trying to run is trying to access this file. Do you want to give permission or not? You can say yes. The same thing. Oh, it's trying to access this path variable. Do you give permission or not? Yeah, and it all works. And this is due to this Deno permission model that I talked before. And even though these permissions are cool when we run our code, they get a little better when we're running others' code, when we can't trust the code. So imagine that you want to build a CLI to generate memes. So CLI, which is me creator, which is the next CLI we'll create. And of course, we will not want to reinvent the wheel. And we were browsing on GitHub and found this snippet that knows how to create memes. What we can do, and same thing as we do on the browser environment, if we have a URL, we can import this code. The same is true for Deno. So we're building a CLI to create memes. You can just come here and say, okay, I want to import this create meme function from this URL. And yeah, this is the URL from the GIST. So any URL from the web will work. If the file is there, then it will fetch it. And as you see, I have this create meme function here that connects to an API, which is apimeme.com, and allows me to send a text to appear at the top of the meme. So with this, okay, I have this create meme function. I want to, same thing, I want to get the meme text from the arguments, and I want to create a meme. So I mean, this is a function which I can click and I have access to it, of course. So because Deno downloads the dependencies automatically, I'll create the meme with the text the user sent for the CLI. So, and with this returns me with a JPEG, and I want to write this to a file. So I want to do Deno write file, called meme.jpg. It's a unit array with a meme. And this should create a meme on my local folder. So, but once again, I'm using a third-party dependency that looks simple for now, but I don't know what is doing, right? So we can just run this prompt and see what happens. So, oh, okay, I'm missing a parameter, which is the text for the top of the meme. So I'll send using Deno. Yeah, so, and then what it says, okay, so this dependency you're using is trying to connect via network to apimeme.com. You want to let it go or not? And you allow it, and it's trying to access this meme or create a file in your local directory called meme.jpg. You want to access it or not? And I'll say yes, and yeah, it says meme created. I can open it to see what it created, and it did this. Where is it? Yeah, so this is currently working. It used an external dependency, but we had full control over what that was doing. So, but what if it was this meme CLI was so cool that you want to share it or you want to distribute it, share it with your friends? Deno also provides you with tools to do that. So if you want to create a binary that's self-contained, which with this meme CLI, you can do it using the command, the Deno compile command. So when you do this Deno compile, you have to send the permissions very clearly. So I'll say this binary will have access to apimeme.com, and it'll be able to write on the current directory. And it will be called meme.jesus, this my CLI. When I do this, it creates a file, which is here, called meme.jesus, which is a binary I can now execute and say meme.jesus. Then there's a heaven for JS nodes. I'll do that, and yeah, it creates the meme. So now I can just grab this binary and share it with my friends. So this is a self-contained binary. For now, it is still a little big, but bearable. So it has 77 megas. But what it does, it contains the full Deno runtime with all its dependencies. You can send it, and people are able to execute it. And these are part of the Deno capabilities. But before we go and we proceed further, what if we wanted to create, for instance, a test for this lines to JSON function? Deno also includes that on its toolchain. So I'll create a test a TS, and I'll once again import my very basic function, and I'll use what's provided by default by Deno to make sure that it's working. It converts lines to JSON. I'm sorry about this terminal outputs. This takes a function. And yeah, so I have my result, which is the lines to JSON. And yeah, I'll send, for instance, Alexandre, return, video, return, just for the sake of testing. And I can send the key, I'll send test. And now I want to do assertions. And remember that I mentioned the Deno standard library has all these features, and that's what we'll do. So we'll go to Deno websites, and we'll have a look at the standard library. So of course, we'll not explore many of these, but Deno provides these standard library features, which are audited by the official team for as many use cases as you want to generate UIDs, permissions, path, whatever. What we'll use here is we'll use the testing ones, and the testing ones are no more than assertion methods. And what we want to do is we want to do a assert equals, so we can pretty much do this. So as I said, we only need the URL to, I have this. We have a URL. Okay, so I'm importing this function assert equals from this assertions file. And if you don't see it, I'm importing this file. And this file here somehow has the assert equals. And if this is too confused, we can have a look at the documentation. Yeah, that pretty much lists all the methods. Here's my assert equals. So when with this, I can write my test. I can come up here. This is bothering me a lot. I can come here and say, okay, so to write my test, I want to assert equals that the result of test 0 equals, for instance, that's the same is true for Jose. And I can now run this, so I can come here. That's JSON. Okay, so I'm glad that it's failed because it means it's working. But yeah, here I have this little thing over the E, and here I don't have it. So glad to see tests failing first. But yeah, Deno test, and it runs the two assertions, and that's it. But what if I have my code all over the place? So what if I have isolation or something? And yeah, so we're all so different editors, different formatters, and so on. Deno provides all of this included. So what if I wasn't using const here and I was using let, for instance? Okay, so this will still work, but then let me run Deno formats. So you noticed it formatted my code, so it's very similar to Go FMT, or very similar to Prettier. So it has one configuration, which it's the Deno configuration, and you don't need to care about it. And same thing about linting. So Deno lint, it says, oh, you're using let, and you shouldn't because you're not modifying anything. So this is all parts of what Deno offers. And of course, you might be saying now, oh, but I don't want to have URLs all over the place in my code. And you're completely correct. Deno provides a way to deal with this that is no magic. So there's no package JSON magic and so on. What they recommend is, okay, so you don't have URLs all over your code. You can just create here a file here for the meme creator, for instance. I'll create a file called deps.ts, and what it does is nothing magical. You basically move the imports there to this deps file, and it can be deps, it can be whatever you want. You just export it there, and from here, you just need your code to import the create meme function from my deps file. And of course, even if you say, oh, but it's a URL, it can change, and it does. Deno also provides a way using the --lock to create a log file and to do integrity checking. So all of that is included on the runtime. One thing I wanted to notice is how we did all of this, and we could create a full-fledged application using only the tools that come up with the runtime. I think that's one of the most interesting things, together with the security module. And the thing that we didn't need to be thinking, oh, am I using on the browser, am I using on the server? So all of that, I think, really simplifies. And so everyone is using the same Deno formatter, everyone is using the same linter, everyone is using the same dependency management, because Deno does that by itself. Those are things that are crucial in every project nowadays, and having it all standardized, I think, helps a lot. Yeah, so before we finish, I'll have to tell you what are some of the current downsides of Deno. So version 1, the first stable version of the runtime, was launched in May last year, and many of the current downsides are also due to its early stage. So currently, Deno supports everything that CS6 Deno supports, as I said, but in terms of compatibility with node modules, so many of them work, but due to these magics that happen on node, the requires, the global functions, all of that. So there's still a layer of compatibility being created on Deno standard library, which I can show you, but it's not fully complete yet. So there's this node, and yeah, so there's part of the things are done, and it basically does things like this. So as there's no magic of having the global require function, what this does is, for instance, it's expose a function called create require, which creates a require function, which is a native polyfill, so that the node modules work. But bear with me, so this is still not done yet, but as Node gets closer to ECMAScript, back to the official language, this module will be more and more supported. I myself have used many Node modules with this, and it worked just fine. Of course, not all of them work. Then it's currently, in terms of speed, is the TypeScript compiler speed, because the TypeScript compiler is still written in JS, and pretty much all of it. So the CLI in Deno, the core is all in Rust, and the TypeScript compiler is still orders of magnitude slower, but they're planning of rewriting it in Rust to make it a little faster. And yeah, I'm not joking, it's really rewriting it in Rust. Then it's still the lack of plugins or extensions, and do not be scared with this. So when I say this is, so you have everything you normally have in Node, so access to file system, access to crypto API, so all of that exists. But in Node, if you want to create something that has a different access to the native, you can create a C++ plugin and have that done. So you can also do the same in Deno, writing it in Rust, and I actually have a blog post doing that. I can share that with you later. But this plugin API, this extension API, is still unstable, meaning that it works. There's, for instance, Deno Mongo, which is a plugin that connects to MongoDB, uses this under the hood. It's working, but of course, they still flag this extension API as unstable, and thus it's subject to change. And yeah, the last point is that on some benchmarks, and Deno takes a close track of benchmarks on their website, you can compare it here. Some of the benchmarks, Deno is better, but some of the benchmarks, it's still not as good as Node. It's not like orders of magnitude slower, but for instance, in throughput, it's not only better, but in HTTP latency, it's now there's a little gap still. And so, but this is being compared with all the versions that, with all the commits of the main branch, and it's on the website. But again, it's nothing too big. But yeah, that's it. Before we go into the giveaway part, I'll go back to the slides just to talk you a little about what's next. So Deno is currently implementing many of the features that are being implemented on browsers, or implementing the native parts. This is true for web GPU. This is true for HTTP2. Yeah, as I said, the plugin API is being worked on, so being sterilized so that people can create Rust plugins properly and in a stable way, and extend the native functionality and create native modules that allow you, for instance, to have a piece of code that is slow in JavaScript. You move that into Rust and you call it from JavaScript, and it works just fine inside Deno. And as I said, I have a blog post doing that, and they are paying close attention to this web platform tests, running those against Deno and guaranteeing that 100% of the tests, so code that runs in browser runs the same way in Deno, and much more. So the Discord channels, the Github issues, so people are very friendly up there. I think I can say that about the whole JS community, but they were always very eager to answer my questions. So I can only say good things. And yeah, and throughout the last year, after exploring Deno in the version 0, I was also on this adventure of exploring one very specific use case where Node really shines, which is web development. And I wrote a book on Deno web development, where I explore all of what I explored here, of course, a little more in depth. And it's also a guided journey on creating a full-fledged web application with Deno, where we go from the simple web server to an application that connects to the database as users, as authentication, as configuration management, and ends up tested and deployed in a Dockerized environment. So the book does all of the, goes through all of that throughout this. It's 10 chapters, and it's what I'm giving away here, together with this spec that you can see here, which is the X Geeks spec, where we offer a bottle, we offer a t-shirt, we offer a pair of socks, and I'll give it away today. So I'll add your names to a randomizer somewhere, and we will see who's the winner. Yeah, I'll add the names while you think of questions, or I'll ask me the questions. So that's it. So thanks. I know I took quite a lot. So thanks for bearing with me, and I'll be open to answer any questions either now or if you contact me later. So thank you so much.
Thank you, Alexandre. Does anyone want to start with a question or a comment? Okay, I'll go. I wanted to ask you regarding the test suite. How complete is it? What can you do with it?
Yeah, so the test suite, so they currently provide the methods for a search, and they provide methods. Yeah, so they currently provide methods for a search, and they provide methods for benchmarking, for timing benchmarks. So it's easy if I look up here. Yeah, and that's pretty much it. So they currently don't provide, they don't want to do much magic in on the standard library, so they don't provide mocking things or stuff like that. So they're trying to encourage something as Golang did, where you either generate files to be mocks, or you have to inject it all and yeah, pretty much do the dependency injection. So they provide the bare minimum, which is assertions and methods to do timing benchmarks. That's what they currently do.
Okay.
Any other questions? Okay, thank you. Okay, so I think we'll proceed with the giveaway, so that we can send to one of you the book and also the X Geeks pack. But yeah, so I'll share the slides, and feel free to contact me if you have any question about the presentation or about Deno, which you think I can help, and be very happy to do it.
I want to say I read the book and it's really good. Nice job, Alexandre.
Thanks.
Just before we finish, I wanted to ask, what projects are there, maybe big projects using Deno in production?
Am I muted? So yeah, so what? So this website is a good list of projects with using Deno. I don't think there's like a giant Deno project just yet, because, for instance, the runtime is considered stable by the team, but the standard library, they haven't released the stable version. So even though I've been using it and it looks stable, they want to finish things first, like the plugin API. So we have some things here, but we still don't have that many things using Deno in production, such big projects. So yeah, that's one of the reasons why I say, why should you care, more than why should you use it just yet on your next project, even though I'm doing it for pet projects.
Okay, thank you.
Kita, how are we in terms of the giveaway?
So actually, it's a good timing that you put that to the table because it was just finished, and the winner is Pedro, and I'm not sure if I'm saying it correctly. And now it's between Faria and Verrume. I think that's how you say it. It's Pedro Verrume, the winner of the giveaway. So you'll get a book, the book, Alexandre's book, and a kit from our side as well.
All right, we just need an address to send it.
Exactly.
So yeah.
And ideally also a point of contact, either email or phone, just to make sure that we keep you up to date with the situation of the package. And you also keep us up to date when you receive it as well, ideally. And a picture and all of that. And also afterwards to share feedback with Alexandre as well about the book, right?
Yeah, I'd be very, very happy with that. I mean, everyone that has read it, and especially like I have this conversation with Porfirio, so I'd be very happy to hear feedback, and of course, both bad and good feedback, so whatever that is, because I think that that's the only way to improve and do something decent. But yeah, I think that's it. As I said, so feel free. So here's my contacts, my Twitter, my GitHub. I can share. I wrote a blog post series about Deno. Where is it? Yeah, I wrote a blog post series where I build a CLI with Deno. I use Deno with Puppeteer, and I create a Deno plugin with Rust. I can share it here if you're interested in those. Go a little bit more in depth on some specific topics. If I know how to find the chat, I'll send it to you. Where is the chat? There you go. Okay. So yeah, so I wrote these are blog posts I wrote with colleagues of mine. Here we, for instance, write a Rust plugin and then communicate with that Rust plugin from JavaScript by dispatching messages. So this is how it all works, the communication with the core. I'm saying this because I mentioned it to the end of the talk. But yeah, feel free to contact me with anything you think I can help, either Deno or not Deno. But thank you.